And here we do have Dr. Gagan Gupta with us as the chairperson for this session. I welcome on the behalf of the Institute, on behalf of the organizers of this national seminar, and on my personal behalf, a heartiest welcome to Dr. Gagan Gupta for being with us in this particular session. Sir, we have total 7 papers in this particular session, and all are pertaining to the theme. I again repeat, perspectives for integration of STEAM in school education. So dear friends, I extend my heartiest welcome to Dr. Gagan Gupta, Dr. Ajit Thomas, who is because of some network connectivity is not unable to continue at present, and all dear participants, those are presenting the paper in this particular session, and rest other my academic colleagues and the friends, those are joining this session as a participant. So I welcome you all for this first technical session, which is named as First A, and theme goes as perspectives for integration of STEAM in science education. We know Dr. Gagan Gupta is a quite renowned name in the field of science education particularly. Dr. Gagan Gupta is associated with NCERT and presently working at headquarters New Delhi. Dr. Gupta has got many publications in the journals of national and international repute. And particularly, Dr. Gupta is involved with the teaching learning of science at the school level and has come up with many of the innovations and the innovative ideas to enhance the learning of the students across the country. I again extend my heartiest welcome to Dr. Gagan Gupta, and I would like to again welcome Sir for the lead talk, which on the title that perspectives for integration of STEAM in science education. So with this, I would like to hand over the session to Dr. Gupta, please.
Thank you very much, Professor Rashmi ji, Dr. Thomas, and all of my colleagues. I can see Dr. Rashmi Singh also. Namaskar, Rashmi ji.
I think now, if there's no problem with Ajit Thomas ji, he would continue.
Yes. That's great.
Dr. Thomas, if your network is okay, you can continue.
It's indeed a matter of great privilege for me to be amongst all of you, to be amongst our own people at RI Bhopal. Because of this COVID, we are meeting through this online mode. This is the power of this online mode today, which has given us many other ways to work together. And at the same time,
please, I'm sorry for interrupting. Sir?
Yes,
can
yes,
you hear me?
Yes, sure.
Very good afternoon, sir. Gagan Gupta, sir, very good afternoon. Due to certain interruption, Aji couldn't join. I would like that Aji please continue the session. Aji Thomas.
Hello, good afternoon to all. Due to some interruption and technical problem, I couldn't join. So, with the permission of the chair, I want to just formally start the session. We have this session on theme number 1, perspective for integration of STEAM in school education, and we are pleasant to have the chairperson as Dr. Gagan Gupta and the co-chair as Dr. Rashmi Sharma. So I request our chairperson, Dr. Gagan Gupta sir, to just guide us with his lead talk.
Thank you, Dr. Thomas. I had already started an initiation from Professor Rashmi ji. That's great. Nice seeing you. Delhi is also quite pleasant today, but I can see that Bhopal is as well. Good weather there. Welcome to all participants here. I welcome on behalf of NCERT and on behalf of my friends at Bhopal to all of you to this session. This STEAM, all of us know that today morning a lot must have been talked about this what is this STEAM, science, technology, engineering, art, mathematics. The word art has been introduced rather recently. Many people say arts, many people say art and design, but whatsoever it is, that it gives an aesthetic sense to what we are doing. So what I have planned to talk to you in just for few 4, 5, 5, 6 minutes is to talk about that how easily or how differently we can talk about science, technology, engineering, and mathematics to the students in general, which can make them to understand these words specifically and clearly. And later, I would like to demonstrate one example, because these are the, I believe I am a physics student, and I believe, and physics is indeed, though I am a theoretician, but uh, the theory, a theoretician's task can never be completed until unless it is experimentally verified. So, well, I will like to give you an experiment in the form of some slides that where I have tried to amalgamate science, engineering, and mathematics together. So first, let us understand what is science. So, as you understand, science is a quest to understand nature. Yes, uh, nature is simple, but the study of nature is complex. We have divided to study the natural laws. We have divided in different streams, different subject areas like physics, chemistry, biology, and many others. So, what science gives us is the laws in their almost universal nature, means the laws of science which are largely empirically driven. I repeat, which are empirically driven, true to all, same to all, at all locations, at all times, whether and at all persons, all individuals, no, all observers. There is a chronology of developing to the hypothesis, and then hypothesis to model, model to theory, and theory to some laws in science. I do not want to talk much about that, but let us talk about engineering. What is the word? What is the meaning of word engineering? Can be understood. The laws of science are, particularly laws of physics, are for inanimate objects. The laws of science are empirical, very stable, universal in nature. Now, an attempt to use these laws of science and to manipulate them within quote marks, I am using the word manipulate within quote marks, quote unquote, for the purpose of mankind. For example, the mass energy equation is a science. The theory of fission and fusion is a science. But how well it can be developed into a nuclear power station or a nuclear atomic bomb or as a weapon, engineering gives us. Engineering, the word engineering deals with those kind of studies where the laws of science can be manipulated or can be tailored or can be used for the purpose of mankind. The word technology is simple, that it gives us that product, technological product, which may be in the mechanical form or in the form of some papers or some tools, etc. It is being said that today's science is tomorrow's technology. This used to be the statement in early 20th century or before. However, the 20th century physics is very important for us, because early 20th century physics, that is the physics developed during 1900 to 1940 or 1945, the first half of the 20th century, that remember that was the time when we had two world wars, we had pandemic, Spanish flu pandemic, etc. But the kind of physics which was developed at that time is still called modern physics. Very prominent, very milestone results have been seen at that time. Now, we have seen, but in today's context, the technology, I must say that technology also leads to the development of science. Let us give an example. Using the basic laws of reflection and refraction, we developed microscopes. Then, using the de Broglie hypothesis and electrons and the electron diffraction mechanisms, we developed electron microscopes. With the use of these electron microscopes, we could experimentally see the molecular structures rather more comfortably. After having seen, so means that the science led a direction to the development of electron microscopes, and in turn these electron microscopes, now in the form of tunneling electron microscopes or AFMs, atomic machines, has given us the understanding of matter better. So this is an example. You can find these kind of examples in all our scientific arenas. This is the understanding, probably this kind of example can be given to our children when we come in our teaching learning sessions to understand these words better. I love examples. Examples are better. I like to quickly, if Rashmiji, can I get 2 more minutes?
Yeah, please, sir.
Yes, Ajit Thomas.
Yes, sir. थोड़ा साउंड कर दो यार, आवाज नहीं आ रही.
Yeah, you please carry
Your
on.
mic is muted.
Your mic is muted, sir.
Sorry, I am sorry. Has it been muted right now, or was it muted right from the beginning?
Right now only, sir.
Okay. I am sorry.
It was okay.
I am sorry, Rashmi, Professor Rashmi, I am sorry. Well, now, if you ask a child, have you ever experienced that moon is closer to us and sun is farther to us? Have you ever tried to explore that the surface of the earth is spherical in nature or curved in nature? Let me first not go to the spherical, curved in nature. Every child will answer the way it has been given in the textbook. But let us try to understand that have they ever undergone any experience related to that? Children, those who are in coastal areas, probably might have seen that when they see a ship coming from a large distance, they first see the flag of it and then they see the whole body. So they can have some idea that the surface of the earth is not flat, but it is curved. What we see in our everyday life, the surface of we can't make this comment that the surface of earth is curved. I give you an example. I have brought over here one particular slide, two, 3 slides to explain what I mean with integrating all those things together with mathematics, of course. Please allow me to present my screen. I am going to show you one diagram, one picture. Where is that? Yeah, yes. I hope you can see it. Let me make it full screen. Yeah, can you see it? I believe that what we are seeing in this. Believe me that this picture was there in the WhatsApp, etc. In all social media a few years ago, but I had taken this photograph from one colleague of mine from United Kingdom somewhere around 10 years ago. And he assured me that this is the true picture. And we asked children that what is this picture? With some guidance, they reached to this, that this is moon and sun. Moon and sun. But this picture has been taken from North Pole. Now, this is an observation which has been seen at the North Pole, where the sun is appearing smaller than moon. While living in Delhi or Bhopal, what we see in the sky, that's probably the sizes of moon and sun are comparable or almost similar, same to each other. You can compare this observation at the North Pole with the observation what we have and at Delhi or Bhopal or in India, anywhere in India or any other else. So now this is, if we see this in this globe, if we see that if we are in this latitude, around this latitude, we'll see the almost same picture. But I am sure that you have seen the pictures taken from Norway, which is closer to the North Pole. There we see as if some moon size has become more. Moon size is larger than the size what we see the size of moon here in India or around this line, this long latitude line. Now, let us try to compare this picture, that our everyday experience, with what we see here. Here we are suddenly seeing the moon bigger than the sun. Now, let us try to connect this with their everyday life. Now, suppose there are two buildings, A and B. B is much taller than A. We are away from this platform, right? Now, if a person who is standing very close to this smaller building, what he will observe? Don't tell him anything. Let us not give what he will observe on the basis of the experiments which he see. He will observe as if this smaller building is much taller than this building. Look at these elevation angles. These angles, I am taking elevation angles, but these are solid angles, three-dimensional angles. Just for the sake of representing here, I have brought them in as a two-dimensional angle. Well, I hope all of us can understand. Since the angle subtended on the eye of this gentleman by this smaller building is more than the size of the elevation angle made by the taller building, the observation is different. Now, if we come at this point, if the child goes back and comes back at this point, and if you see that he will find the two buildings are similar, of the same height, almost of the same height, because the angle of elevations to his eye are almost same. This picture is, however, not to the scale. I hope you will forgive me for giving this schematic diagram. Now, look, suppose if this child goes back by a distance of 200 meters or maybe more than that, then probably what he will see, that he will see the smaller building is small and the taller building tall. Now compare this particular observation which children see every day in their life. This example is very much observable to children at any stage. They can see. So here you can see that if you are closer to the building, that it looks taller, and if you are farther, it looks smaller. That's true. So as you move ahead, move towards the smaller building, it will appear more and more taller, whereas the taller building will appear almost of the same size, which is at a distance from you. Now, if we try to compare this picture with this diagram yet again, it means from India, if you are going to north entire Arctic region, then what does that mean? That probably that the moon is coming closer and the sun is almost of the same size. Moon is becoming bigger and sun is almost of the same size as that we see in India or in the longitudinal line. I'm sorry, altitude line at that area at this point. This combination of these observations together make children to understand. Here is mathematics, you see, here is engineering, here is science. You will see, you can make it that it means that the moon is closer to us than the sun. One can directly conclude that sun is much closer to us as compared to the sun, number one. Number two, this will give you an idea that sun is, however, much bigger. With some extended examples we can make children to understand that the sun is actually much bigger than moon in size. And at the same time, we can make them feel convinced about that the surface of the earth is not flat, rather it is curved, if not spherical at this moment with this example. So this kind of examples we can demonstrate. So there are many others, but this is all I wanted to say in the beginning. I hope Rashmiji will start this technical session with this note here. Let me stop sharing it now. I have already stopped. Rashmiji and Ajit Thomas ji.
Yes.
Yes.
Thank you very much for your guiding session that you have taken and guiding us. Sir, as per the session, we have 7 participants over here. So as it is given here, the presentation would be for 10 minutes, or and we could have another 5 minutes for discussion also, if you permit. And
Yes, sir, please.
okay, sir.
Let us start.
So, okay, should we call upon the first paper presenter?
Afra Alim.
Yeah, Afra Alim.
Yes, sir. Good afternoon, everybody. Am I audible to everyone?
Yes, yes, you are audible, Afra.
Okay. Thank you, sir. Good afternoon, everyone. I heartily greetings to our chairperson today, Dr. Gagan Gupta, and co-chairperson, Dr. Rashmi Sharma. I would like to present my views on the topic, that is integration of STEAM in school education, where my selected theme is perspective of integration for integration of STEAM in school education. I would like to present my screen for that. Can you see my screen, sir?
No, it is
Is
not
this-
visible now.
Just a second, sir. Let me. Is it visible now, sir?
Still, it's not visible.
Not yet, not yet, not yet, Afra, please.
Is it okay now? Can you
Not
see?
yet, not yet. Please share the screen.
Is it or visible now, sir?
No,
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 no, no,
no.
no. Please share the screen.
There is one option for sharing the screen.
It's already shared. Actually, it's saying stop sharing now.
Yes,
Huh,
now it has started coming.
Okay,
Yes,
okay,
yes.
okay. Fine, fine. Okay. Okay. So as I said, my
Yes.
selected theme was.
Make it full screen, Afra.
No, it's full screen only.
Okay, okay, okay. Can you increase the size of it so that it
Sure,
is being expanded so that we can read it?
Is it okay now, sir?
Not, yes, now it is better. Slightly more. You can scroll it up. Slightly more you can expand, or yes, yes, now you can move ahead.
Okay, sir. Thank you so much. Okay. So as I said, my theme is perspective for integration of STEAM in school education. And on the topic, I have started by emphasizing on practical learning of the child rather than the theoretical one. Over there, like as I said in my paper as well, STEAM will be a new phase for school like education system where students will get new ways to work on their ideas and concepts. They would not be only giving us new ideas or new solutions to the problem, but they will also help us in working on the already existing solutions and will help us to give them more defined shape. So continuous, like by the implementation of STEAM, it will actually play a very important role because it will help for the continuous growth of student mind, because while he was doing the thing, like while he was doing the things which he is already learning about, he will understand the theory in a more better way. So like rearranging and rebuilding a base is very important, like as we today right now, as this world is going through a new phase, so we should be coming up with new solution to save it, that can be obtained by rearranging and rebuilding our existing base, that is our education system. Further moving on the topic, I actually explained it. Learning and teaching methodology should be based on STEAM to give it a full success, where the curriculum should be so designed that it uses the STEAM concept productively, where we need to make our educators groomed in such a way that they can make the coming generation readily available for the challenges by utilizing the best of knowledge and concepts. So, in other words, I was actually emphasizing like how we as the teachers, as educators, will be working as a filter for the student. Like we know everything is having a positive side and a negative side. So, what exactly should be reaching out to our student, that is to be seen by us. Further moving on the topic, I also I also emphasize by saying how the practical learning can be like evolved more by including the STEAM in the education system. So I actually highlighted the keywords like STEAM, critical thinking, continuous growth, and all school education system in that. Further, moving in the on the introductory part, I said like in the 21st century, it's at most important to create different learning approaches. People need to understand that it's time to start preparing a child for the future by helping students of all the ages and by shaping their skills in such a way that they play an effective role in the future workforce. The STEAM integration is not an attempt to enhance the framework, but also it also create a sense of creativity in the child. The integration of all five discipline like the STEAM stands for science, technology, engineering, arts, and mathematics. So we have to actually integrate all five of them in such a way that child should start thinking out of the box. Like it should create analytical and creative mindset in the child. Okay. So it will help, it will make kids so prepared for the future that they will open up the vast number of new opportunities, and incorporation on and analytical and creativity, both that I already highlighted before, can be given to students by the effective use of STEAM in school education. It will help kids to work on both to solve almost any problem they face in their future life, because while they'll be doing things by their own hands, they will be readily available for whatever challenges will be coming in their way, like a variety of social and personal matters, either it is of health, environment, or social networking. Every field have indulgence of STEAM. In this manner, children learning about STEAM from this age, small age, and disciplining them throughout their schooling forms their intellectual development. They would be able to go for the best career choices, and their ability to make decisions, which will also show great results. So, not only their academic result will improve, but also they will also enhance their critical thinking skills, and they will help us to set up a new future. STEAM education aims to give students required competency like knowledge and interdisciplinary point of view towards problems. STEAM education integration will help students to connect the content with real life problems, as if compared like to a non-STEAM integrated system where teaching is separate from the real world. Like we used to teach, like before, like if we talk about my time when I was in the 10th class or ninth class, I studied about Ohm's law, I studied about the other such concepts. But when we talk about where exactly it's imply, where exactly they are using it, I failed to do it. So the things which I am learning, which I learned in my engineering times, was actually right now in my ATL labs, like Atal Tinkering Lab, which was initiation started by the government of India, Niti Aayog. Students are learning right now in ninth and 10th class. So that is what STEAM can do if it can get implemented in a proper way in school education system. So collaboration of theory with practical will give like a great bounce. Okay, and like as the early childhood education with STEAM that I was just talking about that, like how right now ninth and 10th students are learning about the things which engineering students are learning few years back. Okay, so over 85% of a child cumulative brain development occurs prior to the age of 6, indicating the critical importance of appropriate care and stimulation of the brain in the early years. In order to ensure healthy brain development and growth, this is why the National Education Policy of 2020, the National Education Policy also have imbibed and inculcated this importance of STEAM in school education, and they have involved the coding part and the robotics part from their learning early learning stage. So they carry actually curiosity to learn about every new thing which they see. I'm talking about the students over here. So they have eagerness to explore and know about things. Since some of them have not undergone that knowledge and ability related to school readiness yet, preschooling children are mistakenly assumed as ineligible in terms of being intellectual deposition, like giving them meaning of experience, predicting hypothesis and analysis. They admire the things around them. That's the thing which we as a teacher can really use it, because when they admire things, they used to acquire it very soon. So moving forward on the topic, by learning of the involvement of STEAM in school education and the education system, it will help to construct the scientific and mathematical connection in the child. Like right now also, as I told you earlier, we have in a school we have ATL lab, that is adult tinkering lab. So there the when I ask student to make a robot which should carry a torque of this much, like assume something any random number. So they used to do calculation like how much the length of the arm should be for the crane, and how much the torque should be applied so that it can take up that much weight. So how this is how the scientific and the mathematical connection can be established to make student learn about the concept. So this is, yeah, moving forward. In today's world situation, our situations are different. Like to deal with real world problem, it is very important to have intelligence which cannot be achieved just by theoretical. So it is important to possess the ability to choose the best approach or combination of approaches that can set in the way of thinking, like how we can combine the things like the fields together and make the child understand about the concepts, like we can teach about how a seed grow by using the art and craft or in the class. So that is how we can work on things. Integration in curriculum, design and implementation, connecting classroom practices with the real world, and focusing on innovation and application are among the tasks that a STEAM teacher is expected to fulfill. This is what, as a teacher, as an educator, we should try to have. Teacher education plays vital role in creating a pool of school teachers that will shape the next generation. Teacher preparation is an activity that requires multidisciplinary perspective and knowledge formation of disposition and values, and development of practice under the best mentors that is being given by the National Education Policy of 2020, and I completely agree with it. Education should not should get proper guidance on how to carry out this process more efficiently to get desired output. Okay, while I was moving forward further in the topic, I told how the integration of STEAM in its education system will increase the creativity and logic or thinking of students, and how the combination of both the logic and the creativity and the practical and theory can give us unachievable result, like which we haven't achieved right now, but the student, the upcoming generation can do. So this approach will make students to work more, to exercise both the left and right sides of human brain as they would need to do in the 21st century working environment. Okay. According to the National Education Association, there are four primary skills areas for success in 21st century. That is critical thinking and problem solving, communication, collaboration, creativity, and innovation. To be successful innovator and creators in the 21st workforce, more emphasis is given to STEAM and related learning. It is making students prepared for higher levels of creativity and effectiveness for problem solving. Okay. So that is the reason so many new ways has already been implemented in the school learning, like the learning system. For example, there is a Montessori learning where how a daily activity, the daily life activities are to be conducted, has been taught to a student from a very from the very early learning stage, from the PPRT classes. They are having this Montessori learning sessions. Okay, these programs actually help students to learn about electronics and robotics to inspire them from very young age in the field of coding. Now, when I talk about the robotics and coding, even the government of India, that is Niti Aayog, started this mission, Atal Innovation Mission, where they have established Atal Tinkering Lab in various schools around the country, where the students are supposed to work in electronic circuitry and robotics mechanics, and as well coding is also introduced in that, where students from very young age are learning about coding. That is really great thing. Now when I talk about this, I feel really proud, like I'm also an aided in charge where I'm teaching students. Now the things which I'm teaching students 5 to 10th standard student that I myself studied when I have done my engineering from electronics and communication. So this is something I see like great task. Like they will understand about the subject from very early age, and they would be able to decide whether I really want to go forward in this field or not. Like this is made for me or not. When they learn about it, they will be able to understand in a better way whether this is what they really want their future to be in this particular direction, or they are made for something else. So this is also help the child to make to take their future decisions. So, moving further on the topic, I have also emphasized on the learning, where I was talking about how this implementation of STEAM in this early age of learning will help them to prosper more in their career in coming time. They will be able to understand how it's going to work while working on practical, as they would have already saw and worked on things in their crucial learning age. So these were the pictures when the students were working on the circuit designing. Like it is taken from the adult thinking lab, which where the students were practicing about the robotics and all. Okay. So further moving on the conclusion, I would like to say the outcomes which we have after detailed study about the topic is that STEAM integration in education system is an important aspect in deciding the country's growth, students' career choices, and overall mental growth. Working on global issues, promoting creativity and critical thinking in these small birds. Our National Education Policy of India 2020 is also designed in such a way that it's altogether inculcating STEAM in school education and in its curriculum. The opportunity should reach all corners of the society so that they can gain knowledge based on this format of learning. Teachers' team teaching capacity could be strengthened by regular training and development exercises and proper classroom implementation. In the words of one of the STEAM teacher, a STEAM teacher should have the same characteristic a STEAM student is required to have. This statement perfectly fits a STEAM teacher, as it is required for the teacher to be strong-minded, always keen to learn new
Dr.
things.
Afra, Dr. Afra, may I request you to kindly wind up? The time is already,
Sure, sir. Sure,
please.
sir. It's almost done. Passionate about new learning, flexible and problem solver. That's all I would like to highlight in my paper. Thank you so much, and his acknowledgement I have given and the references I have taken. Thank you so much for the opportunity you have given me, sir. Thank you so much. It's been a pleasure for presenting my topic over here. Thank you, sir.
Thank you very
Uh,
much.
yes, Dr. Thomas, you were saying something.
Yes, yeah, I just wanted to tell that when for the other participants, since we have time limits, so keep in mind that when we are going to present, keep the time limit in mind so that we
Sure,
could
sir.
complete in time.
Yes, sir.
This was
Really sorry
other
about the
audience.
timing. Yes, sir.
And if anybody has any query or any suggestion, may other participants.
Afra,
Yes,
Dr. Afra,
yes, sir. I'm here.
Dr. Afra, can you open your video, please? Yes, Dr. Afra, while mentioning the references of adult thinking labs, etc., this is just my curiosity that how often you find that the children are uh, not grasping the basic fundamentals of subject or basic fundamentals of physics in particular in the case, rather than they are going to the robotics, mechanical, I mean some mechanical arrangement, mechanical understandings of the instruments therein.
Okay, so so your question is how they are learning about the concepts like science related concepts in ATL lab, not in their regular classes. You are emphasizing on that.
Yeah.
Okay, okay. So here I would like to answer by saying, so like there is, I'm not saying they don't learn something in their normal classes, but I'm saying when they learn about the talk in their class and they know the formula how to make it work. But when they apply that over here in the robotics field, when they make a mechanics of it, and when I ask them like you have to lift up this much weight, how much torque you should apply over it, so there they do the calculation of mathematics over there. There they understand where exactly I'm going to require this in my coming future. So
That's
there
great.
they are learning about the theory, but the practical implementation of it can be taught in the ATL and the tinkering labs.
That's great. That's great.
Yes, sir.
Thank you very much, Dr. Afra.
Thank you,
And
sir.
any other question by any? You stay back, Afra. But maybe people might be having some questions later on. So I
Sure, sir.
request you to stay back during this conversation.
Sure, sir. I'm here. I'm here, sir.
So next we can take.
Thank you, sir.
Yes, Rashmi ji,
Uh,
yes.
before we start, with the permission of the chairperson, I would like to announce a point that whenever the participants are presenting the paper, they need to be focused on some few aspects, and so that will be in time also, and 10 minutes would be sufficient for presentation. You can talk about the objectives, then methodology, then you can straight go to the result and the conclusion part. So that is the way we would prefer if the papers are presented in this particular session. I would request Dr. Gupta also to reflect on the same, so that we smoothly we can our, can cover within
Sure,
the
sure, sure, Rashmi ji, we will be more careful now. This was the first one,
Yes,
so
sir.
I did
I'm
not
really
include
sorry
much.
about it. I was not
No,
knowing
no
about
problem, no
it.
problem. Oh, it's okay. It happens. It happens. It happens.
Okay,
Don't worry.
okay.
Don't worry, Dr. Afra. Don't worry. It's okay. Very good. We all congratulate you. Thank you very much. So the next
Thank you,
is strategies of integrating science, technology, engineering, arts, and mathematics in school education by Aishwarya Swain. Is Aishwarya ji here? Yes, Aishwarya ji. Yes, please.
Good afternoon, sir. Good afternoon, all the
So
participants
yes.
and all the dignitaries present over here. And this is Aishwarya Swai, Research Scholar, PG Department of Education, Ramadevi Women's University. This paper is a combined work of my two authors, and my correspondent author is Dr. Shankar Prasad Mahanti, Associate Professor, Education and Head, PG Department of Education, Ramadevi Women's University. So can I present, share my screen, sir?
Please share your screen, please.
Okay. So is it visible, sir?
So you just rotate the screen of your mobile phone. Probably you are
Yes,
using
sir.
mobile.
Yes, sir. Yes, sir. Is it visible, sir?
Yes, now it's okay.
The topic of today's topic on which I'm presenting is strategies of integrating science, technology, engineering, arts, and mathematics in school curriculum. In the contemporary world, the skills has been receiving more importance than the knowledge, practical and contextual ability than the theoretical knowledge, single subject mastery as well as the comprehensive knowledge of all skills. To address this contemporary needs of the society, STEAM education is the appropriate educational approaches which perfectly blends all the important essence, skills, knowledge, values, and attitude of science, technology, engineering, arts, and mathematics. If we analyze the term STEAM, then it includes five parts: science, technology, engineering, arts, and mathematics. Science includes the logical and empirical part, and technology includes uh, and it recreates and manipulates scientific phenomenon by using knowledge, skills, techniques in order to make our day-to-day life better, easier, and advanced. Engineering engineering includes science, mathematics, and technology, and integrate all these three things to into a functional, practical reality through creative, contextual, and innovative ideas. And art is a way to express ideas, thinking, and emotions in an organized, creative, innovative, and aesthetic way. Well, mathematics can be defined as the science of logical study of numbers, shape, arrangement, quantity, measurement, and many other related related aspects. Probably, STEM includes all five aspects. Uh, then comes why STEAM. STEAM is a perfect blend of education and real life. Why? Because STEAM prepares child to understand and interpret the social aspects and worldly aspects in a sensitive and rational way, and to handle real life hurdles, issues, and challenges with the skill of STEAM, to manage personal as well as societal responsibilities in a better way by utilizing STEAM based interdisciplinary skills such as scientific skills, humanitarian skills, soft skills, technological skills, emotional intelligence skills, public speaking, situation handling skills, and many more. Then, from all these aspects, there are not only the knowledge we receive, but also some skills, values, and attitude we learn. From science and mathematics, child learns the skill of analysis, problem solving, experimenting, reasoning, hypothesizing, logical thinking, observation, and many more. From language, child learns the skills of communication, interpretation, reading, writing, etc. From social science, child learns about their society, environment, social skills, interpersonal skills, social political rules and regulations. So this academic subject,
Excuse me,
yes, sir.
Aishwarya ji, please come to your studies if possible.
Okay, sir. Okay. Then moving to the my point, my subject or my study, the objectives are to design pedagogical strategies to integrate STEAM in school curriculum, and second objective is to frame exemplars to integrate STEAM in curricular subjects, curricular activities, and pedagogical strategies. Methodology here I have followed. This study is based on the secondary source documents and literature reviews through meta-analysis. Then basically I have focused on integration of STEAM in curriculum. Then why there is a need of integrating STEAM in curriculum? STEAM is not about just integrating various disciplines. It is about finding a transition among the subjects and developing skills of each disciplines among each disciplines and their skills among themselves, and also utilizing those knowledge and skills interchangeably. School subjects could be learned based on separate subjects, but when child enters to the real world, things doesn't confront him or her separately. That is why life is about comprehensive more. So to deal with life, all qualities are required, whether it is related to the scientific skill or humanitarian skill. I have framed here an exemplar from which we can understand how the team is integrated in real life situations. If we are talking about building a house, for the preparation of blueprint of the building, a good mathematical measurement, scientific knowledge, and ability to sketch is very much essential. And in order to make this very professional and presentable, architecture needs the help of computer graphics, which is under the technology. To turn the blueprint into the reality, scientific knowledge, mathematical measurement, and engineering skills are required with the help of various technologies. Coming to the economy part, then it decides the budget for the building, which is also a very important skill. Then about the geographical aspects, direction, geographical position where the house needs to be built are also required. After the building of the house, its interior design will be done by an art related skill. So in this example, we can relate how all the skills are required in real life situations. Then strategies for integrating STEAM in school curriculum. First comes the curricular subject. While contain examinations such as sound, light, work energy, electricity, chemical equation, atomic structure, trigonometry, arithmetic, etc. Science and mathematical ideas are mentioned, but along with that, its practical utility can also be mentioned. Students could also be provided experience of how these scientific theories and principles can be implemented and applied in real life, with the help of which technology and with the help of technology and engineering skill, it can be turned into a utilizable form. Talking about the integration of art and humanity in humanity, it provides the science and technology and insight to take all steps with reference to the societal need and well-being. And then comes to the curricular activities. It is not enough to implement STEAM in a curricular subject only. Curricular activities are also very essential. Whatever the child does, starting from sports, games, literary activities, wherever the child must think in a logical way, wherever the situation may be, the child needs to think in a logical way, scientific way. For example, to win any match, strategy is very essential, where analysis and logical reasoning is required, which is a scientific skill. In the same way, when a child wants to learn dance, then it includes both technical training and also needs aesthetic sense in order to make it learn. So here, there is a blend of both science and arts. Then coming to the pedagogical aspect, STEAM-based pedagogical strategy includes problem solving critical pedagogy, discovery learning, field trip, storytelling, role play, demonstration, discussion, narration, and many more. Here, there should not be a disciplinary pedagogical boundary. Those boundaries should be break, and there should be integration of both science specific pedagogy and art specific pedagogical strategies. Here I have cited some exemplars to understand it better. For example, to understand, let us consider the constitutional laws and provision and acts. Here many times it has been seen that to implement those laws, methods of science, laws of society or constitutional laws, techniques of science and technology use. For example, in traffic signals or to maintain the traffic rules, we are using many scientific techniques. And even in foreign countries, whenever a citizen breaks the constitutional laws or traffic rules, automatically fine comes to his or her account. So this is also a use of science and technology. Then coming to the pedagogical aspect, I have cited here some exemplars. For example, while teaching phylum in biological science, it is usually observed that students face difficulty to remember phylum and their respective examples. But if this phylum can be taught through an interesting rhyme or through rapping, then it would be easy to remember and it would in an interesting way. Here, pedagogical strategy of art is proved to be useful because we are using rhymes here. When children are taught about water conservation, they must learn the practical strategy to conserve water for example, learning the methods of rainwater harvesting and implementing it in real life situation. Then coming to the social science, in the same way in history, there is a question about causes behind the decline of a particular empire. So for example, the Mughal Empire. Then teacher may ask children to investigate the factors and causes behind the decline by framing hypotheses and testing them through multiple evidences collected from the databases. Here, this investigation is a scientific approach which has been used in social science subjects. Coming to the mathematics, regarding the mathematics learning, many local level poems and rhymes are there, which includes number system in the form of rhyme. This not only makes the child learn literature, but also makes them learn number system in a very joyful way. Then social science, in order to make the student understand about various social issues and making them sensitive, dance drama, short skit can be the appropriate teaching learning strategy, which is a performing art. This is all about pedagogical methods. And coming to the teacher training, which is another point,
So
along
please,
with the subject.
please finish in 2 minutes, ma'am.
Okay, sir. Along with the subject-specific pedagogical experience, pre-service teachers can also be associated with multidisciplinary pedagogical experiences. There can be separate practical papers of finding relationship among different subjects and flipping pedagogical strategy and integrating STEM. Then coming to the assessment part, assessment should also be improvised based on themes of STEAM, and assessment should not be only memory based. So STEM based assessment technology can help us to assess whether our child has achieved all skills of STEM or not. And coming to the conclusion, there is a need of integrating STEM in school curriculum, not only through curricular subjects, but also through pedagogy, teacher training, and appropriate assessment strategies. Curriculum needs to be so designed so that it should be more skill based and practical utility oriented, which is the major aim of the STEAM. It is both art and science of making things systematic, scientific, and sensitive on humanitarian ground. Thank you.
So thank you, Dr. Aishwarya, for a nice presentation. If there is now we welcome the questions. Please raise your hand and then
Thank you, sir.
can ask the question. Anybody? Rajesh, do you want to ask any question? Anybody who likes to ask? Well, I have some observations on this, Shreya ji. While giving some examples, uh, you mentioned the examples that can be done, but no practical study of doing those examples and seeing the results were matched. Hopefully, you will take on this study a little further to practically
Yes, sir.
see the implications of what you are saying. And on a lighter
Uh, uh,
note, all problems are real life problems.
yes, sir.
So there is nothing like virtual life. Rather, it is better to choose everyday life problems rather than the phrase. Anyway, it's
Exactly.
just on a lighter note. Anyway,
Okay,
uh,
sir. So I have conducted. I have reviewed some articles in which I have found that while teachers are using rapping or rhyme while studying teaching
no,
biological science,
no,
they
that's true.
found.
That's true.
Yes,
That's very true, Aishwarya ji. But we wanted to listen your own study about that.
okay, sir. Okay, okay, okay. I
Okay,
will definitely
I
conduct
hope
a study
you
on it.
will take on this study further and will present
Exactly, sir.
next time your own work uh,
Sure, sir.
rather than
Sure,
what
sir.
can be done. What can be done? Our interest is that what you have done and what you are reporting. What is your experience after that? So, Dr. Ajit
Okay.
Thomas, probably we can go for the next.
Sir, may I please?
Yes, please. Yes, Rashmi ji.
Yeah. So Aishwarya ji, you have presented super nicely. And
Thank you,
I
madam.
join my hands in saying, Dr. Gupta, that we really are interested to listen your own studies, what actually you have done, and later we can imply on the same thing in the
Okay.
different situations in the country. Though it was a conceptual paper as a whole, and I understand
Yes,
since the
madam.
scheme in its own sense is the infancy stage in our country mainly. So maybe more of the conceptual papers we are seeing. The first paper by Afra Alim also was of the almost the same kind.
Yes.
But here I like one thing that you have cited few of the examples from mathematics, from biology, and you have tried to give some strategies for integrating STEAM in the school education. Perhaps I have missed somewhere, and if I can see the slide again, or else you can elaborate something, the strategies you have talked about, the strategies for integrating STEAM in school education. What strategies you have talked? Kindly elaborate within few minutes.
Yeah. Actually, I have five strategies that we can inculcate or include STEAM in curricular subjects, curricular activities, a teacher training program, pedagogical strategy, and assessment strategy. In pedagogical strategies, I have cited some strategies with some exemplars where I can say that while teaching science related subjects, we can include the art related skills so that students will enjoy the thing. But when we are teaching art related subjects, we can include scientific skills so that students can develop scientific paper and science related skills.
Okay, maybe those five bullets you have mentioned, they are the areas, I mean, the curricular and the pedagogy
Correct.
or some teacher
Yes,
education
ma'am.
in which you have tried to find out some strategies. Okay, all right.
Yes, madam. Those
So,
strategies are based on some review articles, and from that I have concluded or I have designed those
okay,
strategies.
all right. So, wish you all the best. We would like to see
Thank you,
you
madam.
with some concrete work in future. Thank you.
Yeah, sure, madam. Thank you, madam.
Thank you very much, ma'am.
So the next talk is by Aribam Pratima Devi on perspectives of integration of STEAM in school education and analysis. We really look for the study which has been done by Aribam ji. And please try to concise the general understandings of the STEAM or of the subject. Yes, most welcome, Pratima ji. Yes, please.
Very good afternoon to all of you present here. And at the very outset, I would like to congratulate RI Bhopal for conducting this wonderful seminar on the much talked topic that is STEAM education. And I am Arigam Pratima Devi, a research scholar from RI Bhubaneswar, Orissa, and I am presenting my paper, which is on perspectives of integration of STEAM in school education and analysis. I hope all of you can see my screen.
Yes, please make it full screen.
Okay, sir. Okay, sir. So this is a scenario of the education today. So a school is presented as a factory where the students goes, and in the school, the creativity, the discipline, and intelligence is drained out, and
Pratima
only
ji,
the
please.
graduates are produced with just their degree.
Pratima ji, one sec, please.
Uh-huh.
Make the presentation full screen, please.
We come to the presentation mode.
Sir.
Down
Yeah.
there, you can see one. Yeah.
You have stopped sharing it. Share it again.
Okay, okay.
Share it again, Pratima ji.
Yes, sir. Yes, sir. I'm trying.
Is this better? Can you present it? See, why just besides the sliding bar, you have
Yes,
few
sir. I'm doing
toggles.
it, but I don't know.
You have
In
few
my
toggles.
screen, I can
Anyway,
see.
anyway, you go ahead. You go ahead.
Oh, yes, sir. Is it visible now?
Make it 100%. In place of 60%, you make it 100%.
Yes, sir. So this is the current scenario of our school. That is, the school brings out the creativity, discipline, and also intelligence from the students. And what it produces is just the graduates with some degrees. So the need of the hour today is to try for creativity and innovation. And we have to make skilled learners. I hope my slide is moving.
Yes, 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 it is.
Yes, sir. And we also have to shift the focus from teacher-centric to learner-centric approaches, which is all of the documents, like our recent document that is National Education Policy 2020 also talks about adopting learner-centric approaches. And we have to integrate technology in our classroom, and we should focus on developing new set of skills, which is the 21st century skills. And we have to adopt and explore of new methods and approaches in the classroom. And we need to integrate learning and experiential learning as innovative pedagogy in our teaching learning process. And also it has to be inquiry based experiential learning. So STEAM education, which is already explained by Gagan sir and also the few presenters before me. So I think this is an interdisciplinary experiential form of learning that expects to reinforce the attitudes of the students and assist
Pratima
them
ji,
with,
slides
yes,
are
ma'am.
not moving.
I don't know, ma'am, what is the problem. I'll just share from my phone.
Yeah, because you are stuck with the one building
Yes,
thing.
yes,
The
yes,
first
ma'am,
slide.
yes, ma'am. Yes, ma'am, yes, ma'am. I'm just
In the meantime, may I request all other presenters, those who are present here, to use a laptop instead of the mobile phone. These kind of problems occur quite often when you use mobile phone. There are limited. If possible, please switch on to your mobile laptop rather than your mobile phones, please.
sorry for the inconvenience, sir. So I was here. So the need of the hour is to look for one innovative pedagogy in our classroom. And also we need to adopt something like STEAM education, which we are talking of. And STEAM education has already been explained by Gagan sir and presenters before me. So I'll not go in deep. I just want to say that STEAM education helps in developing creative problem solving and critical thinking skills among the students. And it helps in connecting real life situations to classroom learning by integrating arts and design in STEM. And it is found that when STEAM is used, then it enhances students' effective and cognitive learning, which has a long-term effect. And also it helps the students to learn in multiple perspectives and influences thinking process, reasoning, aptitude, and creativity. And also it challenges the traditional way of learning and helps connect to real life situations to classroom. So coming to my study, I proposed my research work to find out the awareness of prospective teachers about STEAM and to find out the challenges and concerns of STEAM from their perspectives. The main reason for conducting this research was, as we are talking about integration of STEAM in school, our teachers need to be prepared. And like Aishwarya already pointed out about teachers training, it is very important for us to train our teachers, and the prospective teachers need to have some knowledge about STEAM, as STEAM is very new. So I thought of conducting this research. And with this will, I conducted my research with three objectives. In the first objective, I try to find out the prospective teacher's familiarity with STEAM. In the second, the perception of the prospective teachers about integrating STEAM in school education was studied. And the third was to find out the concern and challenges of integrating STEAM in school education from the perspectives of the prospective teachers. And the methodology I adopted is mixed method research. And for this, I adopted descriptive survey method. And the population was the pre-service teachers of all the regional institute of education in India. And for the sampling, I adopted convenience sampling methodology as it was conducted during the COVID-19 pandemic. And 38 prospective teachers participated in my study. And a questionnaire was prepared with 18 items by using the Google form, and it was circulated to the pre-service teachers, and the data was collected. And coming to the findings, the demographic findings of my study says that total 14 prospective teachers from 2 years MEd participated, which were in the final year. And then from the 2 years BEd, 6 student teachers participated. And from the 4 years integrated course, a total number of 18 student teachers participated in the study. And for the first objective, that is to find out the prospective teachers' familiarity with STEAM, I found that more than half of the samples, that is 63.2%, were familiar, but 23.7% were not familiar, and 13.2% were not sure whether they're familiar or not. And they responded that their source of information were online media, teachers, workshops and seminars, seniors, and friends. And 75.5% of the prospective teachers could report the correct acronym of STEAM, that is science, technology, engineering, arts, and mathematics, but 24.5% could not report correctly. And 91.9% of the participants were aware about the interdisciplinary nature of STEAM, and they strongly agreed with the integration of STEAM in school curriculum. For the second objective, 88.6% of the participants expressed that STEAM could be applicable in teaching learning process. And 66.7% of the participants expressed that STEAM could be used for teaching all the levels of learners in the school, that is starting from starting from primary to senior secondary stage. Then the maximum of the samples, that is 80.5%, expressed that STEAM could be applicable in teaching all the subjects in school because of its interdisciplinary nature. 97.1% of the participants opined that integration of STEAM in school education could enhance higher order thinking skills. The participants also expressed that integration of STEAM in school education will help in developing the 21st century skills, which is the need of the hour. And regarding the concerns and challenges of integrating STEAM in school education, the prospective teachers expressed that it will be difficulty in planning. Like 73.5% of the respondents felt that there might be difficulty in planning a lesson if STEAM is integrated into school education, because as planning of a lesson takes huge time and also it takes efforts, so they feel that it will be difficult. Then the next one is huge classroom size. 51% of the prospective teachers expressed that the huge size of the classroom will make it more difficult for integrating STEAM into school education. And also 52.9% of the samples reported that integration of STEAM in school education could be very time consuming, as we have to plan for activities, the lessons, and everything. And also lack of research could be one concern, as 45.7% of the participants expressed that because of the inadequate school and classroom infrastructure, integration of STEAM in school education could be a challenge. The next is lack of proper teachers training about STEAM. Then the third one is technology integration and issues related to assessment if we integrate STEAM in school education. And the last one is lack of awareness among the common people as well as the teachers and the prospective teachers might be a huge concern for integration of STEAM in school education. So coming to the conclusion, the findings indicate that although all of the prospective teachers were not familiar with STEAM, they were very positive and they were optimistic about STEAM integration. And if the challenges which are identified in the study could be overcome, and we have to give proper attention to it to overcome these challenges. And the research findings in the field of STEAM reveals that it is very effective for developing the cognitive level of students. So we should be very open and ready to integrate STEAM to improve the quality of learning as well as the socio-economic condition of the people. And also we have to educate the prospective teachers also in the Teacher Education Institute about STEAM and the integration of STEAM. That much for today. Thank you very much.
So thank you very much, Fatima ji. What was your sample size?
Sir, only 38 student teachers participate in the study.
Only when your data number is 38, then I really do not understand that what is the meaning of giving the data in percentage.
Okay,
When we present the data in percentage, it means that we have taken more than 1,000 number. Number one.
Yes.
Number two, when you say huge classroom, small classroom, these are pronouns. In research, it's difficult to understand what exactly do you mean with the word use. For somebody, it may be 300 class, a class of 300 is not used. For somebody, a class of 20 is also used. It depends on the nature of the subject. It depends on the other infrastructure facilities provided in the classroom, in the system. So these are the points, few points. People may have different views. Can you answer this quickly? Or any other question, my dear friends, please?
Sir, I appreciate your suggestions and I'll work on it. Sir, the reason for taking only 38 sample was it was
No, I mean,
conducted
I don't, no, point is not this. Point is not, definitely not this, that not 38. 38 is less, we all of us understand. But we understand that why it is, how it is 38. But then presenting the data in terms of percentage.
Okay, sir, okay.
That is my question.
Okay, sir.
When you present the data in percentage, it makes somebody to feel that the number is more than 1,000 or so. Basically,
Yes,
basically in terms of the statistical methods, when we reach to a normal distribution curve, then we give the data in percentage form. But the number 38 is too low for reaching to a normal distribution curve.
Yes.
Well, any other question? Yes, Aji sir, Thomas sir, yes, please.
Any other
May
query
I-
from management side? May I? Yes, madam.
Yes, sir. With the permission of chair, I also have one observation I would like to mention. Pratima ji, at least I'm happy that we could listen one paper, actually research paper in this particular session. So I would like to congratulate you for these efforts. And since you have talked about your paper with reference to the STEAM and that you have tried to find out the familiarity, perception, and concerns and challenges from the prospective teachers. So my question is that why have you chosen the prospective teachers? As far as first two objectives are concerned, the familiarity and the perception, that's okay. But as far as the challenges, the third object is in view we keep. So I feel there should be some logic to know the challenges from the prospective teachers. Those really are not having the familiarity with the routine classroom affairs. So please try to this.
Yes, ma'am. Ma'am, thank you for the question. Ma'am, the reason why I put this objective was when my data was collected, at that time, the student teachers who were in B.Ed or who were in fourth year integrated course, they have already done their internship. So only those, so keeping that in mind, as they have already experienced the real classroom situation and as they were exposed to school. So I feel that this might also give some insight into my study and this might be helpful for the study. So that is why I have put this objective for my study, ma'am.
Okay, but it would be more fruitful if we conduct this study, particularly with reference to the challenges from the teachers. Those are already facing the classroom situations. So we expect, and sometime in future, you would be in some other forum with the same thing. Thank you.
Thank you so much, ma'am.
So now that there is no other question here, so we can go ahead for the next one, Dr. Thomas. Am I right? So
Sir.
this
So next presenter is Deepti Yadav. Effectiveness of
Yes.
analytics-based feedback and gender on study habit for English language.
Good afternoon, respected Chair, Professor Gupta and Rashmi Sharma ma'am, the co-chair. On my screen now for the paper presentation. I hope my screen is visible to all of you. And
Yes.
yeah,
yes, it is.
so yeah, the title of my paper is Effectiveness of Analytics-Based Feedback and Gender on Study Habits for English Language. And as Aji sir has already spoken of the title, I'll straight go to the introduction. The paper is experimental in nature, and just for the sake of introduction, the paper revolves around three variables, which are analytics-based feedback, study habits, and gender. Now, what is learning analytics? As the entire seminar is on STEAM, so technology and arts, these are the two elements which are here in my research work. Learning analytics is very much emerging in the entire world, but hardly known in India. Topic, learning defined as the measurement, collection, analysis, reporting of data about learners and their context, further used for the purpose of understanding and optimizing learning and the environment in which it learning analytics, it is available. Whereas in my doctor, this paper is a part of my doctoral, whereas where I have tried to define what is analytics-based feedback, which is any information about a person's performance of a task resulting from the systematic analysis of data with the help of statistics. Here, statistics is pretty important, which provides meaningful patterns that can be further used as a basis for improvement in performance. Technology helps us actually to get the patterns, which is very easily available once you use online education. Now, study habits, as we know, it is everyday conduct or behavior towards learning. And it is not 1 day or 2 day or 2 months. It is formed over the years since the formal education begins. Now the objective and hypothesis of my study, uh, it is given here. I had only one objective: to study the effect of treatment, gender, and their interaction on study habits. Study habit is the dependent variable of my study of students by taking their pre-test scores of study habits as a covariate. Now, as we can see in this objective, we can draw three hypotheses. So the first hypothesis is there is no significant effect of treatment on study habits of class 11 students when their pre-test scores of study habits were taken as covariate. Second hypothesis was there is no significant effect of gender on overall achievement in English language of class 11 students when their pre-test scores of study habits were taken as covariate. And the third one was there is no significant interaction of treatment and gender on study habits of class 11 students when the pre-test scores of study habits taken as covariate. Now, the method that I used for my study, it was a quantitative study and experimental in nature. Non-equivalent control group design was used for the study, and I used ANCOVA for the analysis of data. The sample method was non-probability sampling. Class 11 level was used for the study. It was study in Bhopal of Madhya Pradesh. Now the sample comprised of 81 students of class 11, and the sample was from KV number 1, Bhopal. Experimental group had 39 students with 11 girls and 28 boys, whereas control group had 42 students with 22 girls and 20 boys. The instrument that I used for the study was a standardized one. It was Palsne and Sharma Study Habit Inventory, mostly known as PSS-HI, and it was standardized in the year 1989 and used still in the various other studies that I cited. This instrument is a 3-point scale with 45 items, and the reliability coefficient was found to be 0.67. This is the result of my study. As you can see that, in here, if we see the treatment, it was significant at 0.01 level, whereas there is, it wasn't significant for the gender, as we see in here in the table, and even for the interaction. So the finding and conclusion I would like to present before the chair and co-chair. For the objective one, it was concluded that the feedback with analytics-based feedback method was found to be significantly superior to traditional method in terms of study habits, where pre-test scores of study habits was taken as covariate. For the objective two, where gender was in question, so it was concluded that the study habit was found to be independent of gender of students when pre-test scores study habits taken as covariate. Whereas for the third objective, it was again concluded that study habits were found to be independent of interaction between the treatment and the gender. So for the discussion of the study, I would like to mention that analytics-based feedback method was found to be significantly superior to traditional method in terms of study habits when pre-study habits level was taken as covariate. Another finding was that study habit was found to be independent of gender when pre-study habits level was taken as covariate. Further, study habits were found to be independent of interaction between treatment and gender when pre-study habits was taken as covariate. So, with my paper, I would like to conclude for this present seminar that learning analytics has the potential to improve and enhance learning with improving study habits. Because as we are talking about technology and arts in here, so yes, arts language can be improved with the help of technology, and therefore, analytics-based feedbacks can be instrumental in bringing desired changes as it targets the problem areas of study habits. These are the references that I cited for my study. Thank you so much for listening to me. I'd like to get the questions. Yes, sir.
So very good presentation, Dr. Yadav.
Thank you.
Rashmi, if you have any observation on that, please share.
Yes, sir. Deepti, it's a good paper indeed. But
Thank you,
I'm
ma'am.
trying to look into for STEAM in the paper. I mean,
Ma'am,
something I could see it's English class 11 students. You're talking about the study habits. So
right.
kindly
Yes, ma'am.
elaborate.
This was, as I talked about, analytics-based feedback. This feedback wasn't given in the classroom. There was a course which was developed on Moodle. Class 11 was taught online, for this. And the entire English language course was created online, where they were supposed to, given this Pasne and Sharma, the entire instrument was uploaded online. Technology was particularly used in order to provide the feedbacks. How they, responded to those items. Those items were analyzed with the help of, online the responses, whatever were given, they were looked into with help of a pie chart. As we know, if we use Google Forms, they can be easily transferred into this pie chart with the help of Google Analytics. So that was used. If I'm allowed to use my screen once again, um, I just would like to show the screenshot of the I had submitted. I just share my screen once more so that I can reply to your answer, ma'am. Um, I hope my screen is visible now. And ma'am, this is, in fact, when I submitted the paper, this is the dashboard of the My Learning class. It was the technology which was dominant in this study. As you can see, the entire course for class 11 was developed on this particular platform, and students were given the feedback with the help of this platform. So it was an integration of arts and technology. So I hope that suffices, your query.
Okay, all right. Art and English, we could technology we could see. Yeah.
Yes, ma'am.
Okay, Dikti. Thank you.
Thank you, ma'am. Thank you for your question.
So thank you very much, Dr. Yadav. So, Dr. Thomas, may I please, maybe please move ahead for Dr. Sai Latha's paper on STEAM versus traditional teaching, the way forward. Yes, I expect Dr. Sai Latha will present her work, minimizing the review kind of work. Thank you.
Sir, hello. Sir,
Yeah,
am
we
I
can
audible?
listen you. Yes,
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 madam.
we can listen you.
You're audible.
Okay, sir. With due salutation to all the dignitaries, team members, dear participants, good afternoon. This is Sailata from Andhra Pradesh. I am working as headmistress in Jilla Parishad High School, Vaviltota, Putalpattu Mandal, Chittur district of Andhra Pradesh. My topic for presentation is STEAM versus traditional education. Before presenting my topic, let me share with you why I choose this topic for presentation. Mainly, three issues made me to think seriously about this present teaching methods. The first one, COVID pandemic situation. The second one, number of suicide attempts by young people. The third one, Prime Minister's call of Atmanirbhar Bharat. So let me come into the topic. What is STEAM? STEAM stands for science, technology, arts, and mathematics. With the addition of arts into the STEM program, evolved STEAM. Addition of arts into the STEM approach would further enhance the credibility of the program, as arts has the capacity to lure children and teachers into the system. How is STEAM different? Traditional way of teaching was relying heavily on the students' memorizing capability rather than on the knowledge applying capacity. Examinations and assessments are also based on the memorization of the subjects. Studying consists of mostly retaining the knowledge with no concept of application by the students. However, STEAM education system is focused on experimentation and ensures that the child understands the mechanism behind the experiment. With the integration of STEAM into the learning curriculum, students will be equipped with the knowledge of applying these principles, equations into real life scenarios apart from retaining the subject. A picture is worth than 1,000 words, and a video is worthier than that. With the introduction of technology into teaching, learning would become more effective, efficient, and wherein the students get to see a broader perspective of what they are learning. STEAM education is known to kindle the interest of the child in all the subjects because here the child gets to do more than by heart more. Traditional teaching involves covering different subjects without delving deeper into any aspects if the child wanted to learn more. Whereas in STEAM, with the application of practical aspects into learning, the child can explore new possibilities and would be able to play around with the things surrounded by them, which might lead to more innovations and inventions. Why is STEAM important? The 21st century skills are entirely different from the older ones as technology has taken a center stage in everyone's life. STEAM will be able to equip the child with this essential skill in order to survive and progress in their real lives. With the traditional teaching, with the didactic way of interaction, few children are quick enough to lose interest and subsequently labeled as laggards and pulled down even further. With the introduction of technology into teaching, the teaching become more effective, interactive, inquisitive, and a fun way of learning, which can retain more number of children in the classroom and subsequently reducing the dropouts from the school. STEAM curriculum is based on the concept of student-centered interactions rather than lectures. Traditional education is focused on replicating the correct hypothesis, while one of the most important pillars of STEM module is to build creativity, according to the recent Times of India article. STEM is focused on stimulating the brain and giving it a free rein to create rather than simply replicate what is already known to the world. With the integration of arts into the STEM has become more appealing as arts has capacity to lure the attraction of teachers and students and in the STEM curriculum. The traditional teaching system is completely focused on books, numbers, and syllabus while ignoring the practical aspects of these equations. Probably that is the reason why many of us even still able to recollect all the theorems, quadratic equations, and be completely ignorant of the fact that these are utilized in modernizing our lives, infrastructure, and homes. This scenario changes with the implementation of STEAM. In its core values, STEAM aims at teaching kids about topics like quadratic equations by actually highlighting its importance in real life scenarios. Traditional way of education runs on a set of rules which are rather stringent, and this might help in reproducing the theories correctly but suppresses creativity. STEAM aims to build creativity by stimulating the brain and giving it a free rein to think. Hence, STEAM focuses on creativity while the traditional teaching on replication. Another argument against traditional teaching is that it never prepares the child for their life. This has become a serious concern of late, considering the number of suicides by young people, which is really a disturbing scenario. The STEM education, however, can address this issue by making the students think out of the box and be able to bring out more entrepreneurs and leaders among them who can lead the society in a better, responsible way. COVID-19 and STEAM. This COVID pandemic altogether posed new challenges with the current education system, which was more evident in rural areas and government-run schools. While the schools from cities and urban localities can easily transform into the online teaching programs, children from the rural background were left out in the race. This change by the farmer group was possible only with the integration of technology into education system. With the evolution of culture, technology, embracing STEAM seems to be a viable option for
Hello,
our future
excuse me, madam.
generation.
Sorry to disturb you, interrupt you. Actually, our chairperson, Dr. Gagan Gupta sir, has some other urgent uh, where he have to go for the lecture. So I want to thank Dr. Gagan Gupta sir so that he was with us during the entire session for the inputs he has given to the participant, and I think so it was valuable for all the participants who have given their presentation, and whatever suggestions has been given by sir would be taken by the participants who have presented the paper. So I want to thank Dr. Gagan Gupta sir once again. Thank you very much, sir. Okay, madam. I think sir has sir has exited, so you may continue, madam, now.
Okay, sir, thank you. With the evolution of culture, technology, embracing STEAM seems to be a viable option for our future generations. Innovations and STEAM. All the recent innovations by young talent across India, which was showcased in school fairs, was only possible because the students could push their boundaries, imagine bigger things, and could make them work together. This should be the goal of education system that any country is practicing to be able to compete in the real world. For a populous nation like India, there is no dearth of talent in any field, provided we give the children the opportunity to evolve themselves in a better way and show them the path to achieve the things which could have been impossible otherwise. STEAM curriculum aptly suits into this scenario of changing trends. Atmanirbhar Bharat and STEAM. With the Prime Minister's call of Atmanirbhar Bharat, wherein India is aiming to be a self-sufficient in all the fields, there is need for reforms in our traditional thinking, teaching, and STEAM education system is a way forward towards that goal. Traditional system was always skeptical of students posing questions and challenging existing concepts. Whereas in STEAM, the child is free to express his or her views, opinions, and challenge things. Change is the need of the hour, and this is possible only by thinking in a broader way and giving the students free hand at it. STEAM and research. World always needs evidence to prove things. This is possible only if research is encouraged from childhood. India, though a hugely populous country, is lagging behind in terms of research, and this could be addressed if the children are encouraged to document their ideas, share with their peers, and convince them of their new ideas. This could be the beginning step towards encouraging students' research in their later life. STEAM, with its idea of exploring new possibilities, could pave the way for further future research projects in India. It's high time that we challenge our traditional chalk method of teaching and step into new possibilities of STEAM teaching in order to reap the benefits of this system for our future generations. Here are few suggestions for implementing STEAM. Equip the mentors with necessary training in order to facilitate the smooth transition from traditional to STEAM teaching. Integrate the technology into schools from rural backgrounds in order to encourage the rural talent. Revise the current curriculum and bring about the changes by forming committees represented by different sections of the society. To bring about student-centric education and encourage them to be a part of the system. To bring about financial literacy right from childhood. Sex education to children in order to impart the necessary knowledge to them in a right way. Modernize our laboratories to encourage children into research activities. Integration of STEAM into farming sector to improvise agriculture and encourage the future generations to make it a viable living option. Encourage the teachers and students to embrace new technologies and bring about the necessary reforms. Make India a global hub for STEM activities by organizing exchange programs with other nations, aiming to become a global power yet retaining our traditional cultural values and bring about peace and harmony in the world. With a few sentences, I would like to conclude, sir. STEAM is an efficient way of learning for the children going forward, which can address various uncertainties of the future generations, like the nature of jobs, and prepare them to embrace the opportunities of life. Developing nations like India should effectively implement STEAM and equip the children to become global partners and leaders in technological innovations and excellence. Thank you. Thank you for giving me this opportunity. Thank you once again.
So thank you, Dr. Sailata ji. Yes, STEAM is a matter of mindset rather than a matter of practice. First, it has to be done in the mindset. Uh, any question from anybody? Largely, you have presented your observations on the concept of
Hello.
Sir, you're not audible. Net up. Hello, sir, you're not audible. Hello.
Yes. Now I'm back.
Sir, you're not audible.
I'm back, Dr. Thomas.
Now you're audible, sir. Now you're audible.
So there was a power.
I think, sir, there is some network problem from your side.
With us probably. Can we call Dr. Thomas to him?
Yes, sir. We can call upon the next participant.
Yes, yes. Mohita
Uh,
Khan.
so the last participant is presenter is Mohita Khan. Are you there, Mohita Khan?
Yes, sir. Hello. Good afternoon,
Yes.
everyone.
Okay, try to
I would like to.
within time.
Okay, yes, I would like to directly go to my presentation, if you allow.
Please,
Main
please go ahead. Please
methodology,
go ahead.
your conclusion, and your study objective.
Is it visible, sir?
Yes, yes, it is visible. Very
Yes.
good.
Okay, so I am Mohita Khan. I'm going to give my presentation over steps and strategies towards integrated STEAM education in Indo-centric school classrooms. I'm not going to discuss any examples, but for my understanding from my research and other things, I would like to give some steps and strategies to follow for the teachers and obviously researchers to better integrate STEAM education in India. So this will be the outline of my presentation. I'll be discussing what the STEAM approach is and do we need a STEAM approach, my research questions, and then my study. So I'm not going in detail. So we already know what is a STEAM education. STEAM is definitely the integration of arts and STEAM. But what this arts can do is definitely a wonder in between the science and arts. By utilizing art, the students can use the fine arts, music, visual art, physical arts, and the different aspects of arts to understand the science, to better understand the science, and to give better interpretation of the ideas, the better the imagination, better the creativity, and this step in this STEAM approach is definitely a good one. I'm sorry, sir. Are you saying something? Okay, I'm going forward. So STEAM is definitely a good approach, but the question is it feasible for India to adopt a STEAM approach in our classrooms? It's good to go with the STEAM approach. So I would like to study and identify whether we need the STEM education or is it feasible for us to. Then for me, if you ask me, is it good to have a STEAM education? Then yes, it is the right time to go for the STEAM education approach because we are already having a lot of school in India is already having traditional classrooms, and after this COVID hit, we are in a transition phase where the school are already making hard to keep pace with the technological phase, and technological enhanced classrooms are already under construction for many of the schools. So yes, we are in a transition phase, and we can have this STEAM approach as well. And the schooling is very much pressurized these days because the students are more pressure under the NEET preparation, the JEE mains, and so on. So if we add the arts in science, it will be a more fun. The science will be more enjoyable, and obviously there will be a more no pressure environment for the students with STEAM approach. And teaching was also not all, but majority of the school teaching is lecture-based teaching. Many of the schools only give lectures and they don't put focus on any activities in the schools. So this type of approach in the schooling will obviously develop skill development among the students, and it will be a good approach for education in India. It will also enhance the interdisciplinary learning and the higher order thinking skills among the students. So it will not only be the rote learning, like you learn something, you put it in the exam paper, and you get the result, and you are a good student. So this approach doesn't follow this. And in the end, this adaptation, the STEAM adaptation, is obviously an easy adaptation. Easy adaptation in comparison to the many other high adaptation or any other things. Like you don't have to do much, but you have just with slight motivation and slight creativity on the part of teacher and slight preparation and planning on the part of the teachers can bring much engagement from the students and much excitement in the science classroom. So yes, STEAM is a need of the hour for Indian classrooms, and we can have it successfully if we follow some steps and strategies. So the research questions are for this research which I studied are, what are the steps? Are there any steps like any procedure to integrate the STEAM education in Indian classroom? And are there any successful strategies, like there are any ways to successfully implement it, no matter what topic you are teaching, whatever you are doing in the class, but are there any strategies like to follow something or to keep something in the mind the teacher can successfully implement the STEAM education in Indian classroom? So to answer the first question, the steps of India, I first identify the needs from the teacher, what a teacher need to do to ensure that the STEAM is the class is a steam up, it's activated the steam approach. So first is the focus on the problem, that the teacher should first focus on a problem, that from a topic or something like that which can relate both STEM and arts. Not all STEM subjects, not all not everything, but maybe on some, because we were talking about so many things that teachers say that we don't have time, we have to fill the curriculum, we have to follow the curriculum, we have this to do, we have that to do. So not all, but even in some, just in the beginning, we can have something like they can choose some small topics and then focus on some that topic as a problem and give the students as a project work. And then in those projects, they can have STEM and arts as each other. And obviously for it, the teach on the part of teachers give planning to teach themselves what you are supposed to do, and teachers should engage engage the students, that they are engaged in discovery learning, their mental abilities are involved, higher mental abilities, especially their creativity, their critical thinking abilities, they should be engaged. And this can be done through the teachers. The teachers can ensure that these criteria have met, and they should help and guide students in forming the problem. So it's not like they give the solution to the problem to the students, but it's like they help the students to get a solution to a problem. And problem here means to work on any of the topic, any, it's like any. So, and given the students opportunities for the feedback and reconstruction of their solution is also very important. So these are the things I recognize that are important on the part of teacher. But if you talk about step-by-step procedure to implement the STEAM or integrate the STEAM in the Indian classrooms, then it should be like this. I have made it like, first the teacher can select a topic that can include all 5 aspects of STEAM, if not all, at least 2, and 1 art and 1 any of the STEM subjects. So one of the subjects you can choose, the teachers can choose, and then it should be, it's good if the problem is connected to the real world problem, so that the students get engaged in it, students get more interested in it. Yes, we know it, it's just not the rote learning, it's just not something we are reading in the books, it is something related to their life. And then defining to them what they are supposed to do using an engineering plan. What the engineering plan here means, like design something, research over something, you have a problem, research over something, you have some solution, and you test it. If you test it, it's good. Like it's the same as we did hypothesis testing in social sciences. So these is you explain them that you have to do this, and this is the way we can do this, and engage them, help the students to research and involve in brainstorming, use their mental abilities, higher mental abilities, guide them to form a solution, then testing the prototype solution they have come across, and obviously then give the results. Like if you have come across something interesting, then show it to other students, show it to the other teachers. It will give motivation to them. And if there are some problems in the solution, if there are problems in some project work, then they can always have they can always redesign it. So these are the steps a teacher can follow, a researcher can follow to steaming up the classroom, to involve STEAM education in the Indian classrooms, because this is important on the part of teachers. Now the strategies to integrate STEM in India. In India is obviously there are 2 intrinsic strategies that are important worldwide as well, but in India as well. That is, first is the teacher professional development. Obviously, the teachers, all the teachers who are going to integrate the STEAM approach in Indian classroom, they should be able, they should have some training, they should know what they have to do, they should know what they're supposed to do and how they can do it effectively. So for this, in intrinsic strategies, the extrinsic one are the training to the teacher and providing training on a big scale, on a big country like India. It's not possible to have training centers or something. We can have both online and offline mode teaching trainings, so that a teacher from rural areas or teacher from everywhere, they can connect to those classes and those centers who are providing the teacher professional development courses, and they can learn how to steam up the classrooms. And in-service and pre-service training can also be given. So it's not always the teachers who are teaching, it's always the prospective teachers who are in BA or MA classes. They can also learn about such a process, so that in future, when they become a teacher, they can utilize such a process in their teaching. And different languages, obviously we are a country with different languages, so the courses must be such professional development courses should be available in different languages. It should be available to all subject teachers, and if possible some incentives can be given to the teachers to motivate them to come and join such courses, so that they join and come and learn about it and use it. Incentive in the terms of like certification, if you do some certificate, if you do some course you can get some certificate, so they can come and do these certificates, and they learn how to steam up the classroom, and they will in future apply this steaming up approach in the science classrooms or arts classroom in India. Second is curriculum development. The second intrinsic strategy is curriculum development. Obviously, if you have this want to integrate the STEAM approach in India, you should have a curriculum material which you use in the classrooms. But these materials in context to India, it's not always easy to get the new curriculum material all of a sudden to all the cities and the urban rural schools all. So if the curriculum is easy, self-made, if the teacher makes sure that the curriculum materials are self-made, like made by the teachers or jointly made by the students and the teacher as a project work, then it should be easier to apply and use by most of the teachers. It should be reusable. Like if you make some project, it can be used by the other teachers in their classrooms at other levels. It can be used by other teachers in other schools. So it can be used if it's reusable, then it's good because it's cost effective. That is the matter in Indian in our, because there are so many schools who don't have funds, even if they had funds, there are so many problems with money. So if the projects are cost effective, then it's easier to apply. So and gender equivalent, obviously there should not, we are talking about social sciences and the integration of social sciences in science, then we should keep in mind that the project should be gender equivalent. It should be made in different languages, and obviously it should be multifunctioning, like they can be used by different subjects. If not, the project made by science should be used in science only. It can be used by art. There could be some I'm not talking about the examples what they could be, but yes, if we focus about such things, that we are going to create some curriculum material that is cost effective, reusable, easy and self-made, and teachers can be motivated to use it and make it, and they can effectively use it in the classroom for the STEAM approach in India.
Madam, please conclude.
Yes, there are other strategies like infrastructural development. There are also there can also be inter-school and intra-school collaboration. STEAM related guidance and counseling services can also be provided, so that the teachers get motivated and know what exactly this approach is. And the conclusion of this whole research and study is the STEAM approach is effective. It is an initial stage in India, and with proper understanding, STEAM education can be successfully implemented. Like if we follow the steps successfully for the intrinsic steps, and for successful implementation, the intrinsic strategies and definitely which are definitely the teacher professional development and curriculum development programs are important. In addition to intrinsic, the extensive strategies such as online offline mode of classroom, limited cost curriculum material, etc., can be provided for better implementation of STEAM education in India. Thus, with proper planning and step and strategies, I'm sure that STEAM approach to education can be an effective way to enhance creativity and critical thinking in STEM learning in India. Thank you.
Thomas, your mic is mute.
Hello, am I audible?
Yes, sir.
Yes, now.
Yes, sir.
Hello.
जी बोलिए थॉमस जी
You
बोलिए.
are
Ah,
audible,
okay, okay.
sir.
So, madam, we have, I think so. We finished with all the presenters. Altogether, we have 6 presenters. Uh, we had 7, but one couldn't present, so we had 6 presentation. So, at the last, I want to, if I, Gagan sir, are you there? Huh? I think so. Gagan sir has left. He has informed me that he has another important engagement. So I think so. He has left. So I request the co-chair of the session, Dr. Rashmi Sharma, to give the final remark or observation, suggestion for all the presentation that has been made. Madam, Dr. Rashmi Sharma.
Thank you, Dr. Ajit Thomas. As you have rightly mentioned, there were 7 papers to be presented in this session, and out of 7, 6 has been presented. I would like to bring into the notice of we all what these papers were and what all we take from this particular session, which talks about the perspectives of STEM education. There were the first paper which was presented by Afra. I think she
Yes,
has,
ma'am.
Yes,
the Afra, she has talked about the STEAM education. Basically, it was the conceptual paper in which she has focused on the innovation, what all innovations could be done in this particular field. And she has talked about the resource generation, and she has talked some part of the paper has talked about the teacher education only, and particularly she has talked about some of the skill development, the primary skill development, which is focused in the NEP 2020 also. Those talks about the development of critical thinking, communication skill, the collaboration, and the creativity and innovativeness. So these were the aspects. Those were touched in the Afra's paper, which entitled as Integration of STEAM in the School Education. More of this was a conceptual paper, and we expect that Afra would come sometime with a real research paper in some of the forum by having the basis from this particular seminar. The another paper was presented by Aishwarya. Aishwarya has talked about the strategies of integrating science, technology, engineering, arts, and mathematics in the school curriculum. Here, starting with the defining the STEAM, what is that? The Aishwarya has touched upon many of the examples from the different school level disciplines like mathematics, biology, physics, etc. And then she has talked about the various strategies. And in this paper also, we could hear quite properly that what is the need of the STEAM education in today's time, and how what all strategies can be deployed for this very purpose. The third paper was presented by Pratima, and it was really a good paper in the real sense. It was a well-researched paper, which was done with the help of the prospective teachers. And so in this paper, she has come up with some data, and she has talked about the perspectives of integration of STEAM in school education. It was analysis-based paper. Well done, Pratima. And the next paper, which was presented by Deepti Yadav had talked about the effectiveness of analytics-based feedback and gender on study habits for English language. Though, in my personal opinion, I could not find more of the STEAM content in the paper, but she has tried to defend, and she took the example of the English and the integration of the ICT somewhat like that. So anyway, it is a good paper, but not very befitting for this particular forum. Then the paper was presented by K. Sai Latha. Madam Latha has talked about the STEAM versus traditional teaching, the way forward, and she has advocated quite properly that the traditional way has to be uh, provide space for the STEAM in the Indian education system at this high time. And it would have been better that if Dr. Latha would have come with some presentation, or at least something, because it was a simple audio, and we understand the base cone of experience also. It hinders the understanding of about the presenter's ideas if it is just simply spoken. Anyway, congratulations, Latha ma'am. And the last paper, which was presented by Mohita Khan, steps and strategies towards integration of the STEAM education in Indo-centric school classroom. That's also quite a good paper. In fact, more of the conceptual papers we could listen in this particular session. And session was on the perspectives of integration of STEAM in school education. In a way, all the presenters has tried their best to incorporate the different aspects of STEAM education and the proper integration of this STEAM in the school education. On my personal behalf and behalf of the Regional Institute of Education, Bhopal, I would like to convey my heartfelt congratulations to all the presenters, those who have presented the paper in this particular session. At the same time, all the participants, those who have been part of this technical session and has been giving their inputs and suggesting some points to the presenters and sharing their experiences. My thanks to them all. And now I would like to hand over this forum to Dr. Ajit Thomas. And at last but not the least, my heartfelt thanks to Dr. Gagan Gupta, who was chairing this session in his absentia. Dr. Thomas, sir.
Thank you very much, madam, for a very elaborate conclusion of all the presenters, what they have done. So at the last, I just want to give the official word of thanks. First of all, I want to thank the eminent chairpersons of today's technical session, Dr. Gagan Gupta. In spite of his busy schedule, he has taken his time and given his valuable inputs, suggestions, and I'm sure that all the participants would take those suggestions and they are going to improve the paper. And uh, although he has left, beside being busy, he has come and he was almost towards the end of the session. And I want to thank the co-chair of today, Dr. Rashmi Sharma, madam, who has given the valuable input right from the beginning. From each presenter, she has given input, suggestions, and I'm sure that those suggestions would also be taken by the presenters who have presented in this session. Um, I think so. All the presenters has given justice for the presentation that they have made, and I'm thankful to all the presenters, all the 6 presenters who have presented in this presentation. And I want to thank the coordinators of this program who has given me this opportunity for conducting, for moderating this section. At last, I want to thank one and all. Thank you very much.
Thanks to Dr. Thomas as well.
Thank you, madam. So with the permission of the chairperson, could we leave this meeting now?
Yeah, please, we can leave. And congratulations for nicely conducting this session, Dr. Thomas, and all the participants for their participation. Thank you very much. We can leave now.
Thank you, ma'am. Thank you so much, ma'am.
Thank you.
All can leave the meeting. Thank you very much.